So, Thursday, November 13th, we officially made history, launching the escapade mission, the Blue Origins, straight to Mars. And currently, it's about 1.5 million miles away from Earth, and it's going to be following a kidney bean shape around Earth so it can make a full trajectory to Mars. And a trip to Mars like that for these twin origins basically is going to take 22 months to make direct shot to Mars, and it's going to understand the history of Mars by understanding all the questions that we're going to be asking. What happened to Mars's atmosphere? What is left of the atmosphere? What's happening with the magnetosphere? And also what's left of the magnetosphere? We can all piece these together to understand Mars 4.5 billion years onward and what's going to happen to Mars in the future. But there's an interesting topic that I mentioned during the evolution of Mars in the last video. Let's understand there was a certain time period similar to Earth where Mars went through an ice age. Not just one ice age, but multiple ice ages that triggered what Mars is today. Let's talk about it. So let's start with the chapter of what happened to Mars before the ice age happened. So, we're going to actually place the story about 3.8 billion years ago. And this is during the time when Mars and Earth basically had water, as rivers, lakes, oceans, etc. And during that time, if you look underwater, there are these chimneys, these volcanic chimneys that was whipped up by the planet's interior, basically. And inside all that steam was a soup of living microbial organisms, bacteria, and other life forms. And eventually all those spread across the planet, filling the entire planet with life. The first primary proto-life. But all of that evolved until we get to 3.5 billion years ago, the first confirmed piece of life. 3.5 billion years ago. And look no further than stromatolites. Stromatolites are basically these massive blue-green algae that form like a rock-like structure, and their purpose is photosynthesis, basically taking the sun's energy and then eating up the CO2 that was left over from previous volcanisms from early on in its past. So it takes all that CO2 and it lets off all this oxygen. So now you had a complete balance. But something happened as the stromatolites evolved, basically. So now, 2.5 billion years ago, Earth and Mars experienced at the exact same time its very first ice age. Basically, extreme amounts of O2, right? Extreme amounts of oxygen. Pretty much triggered the very first ice age because there wasn't enough CO2 to trap in heat, keeping Mars and Earth warm at the time. Also, you have to think about the sun's luminosity at the time. It was actually much weaker than it is today. And this actually triggered the snowball Mars and a snowball Earth. That was its very first ice age. So now we're going to get to the next chapter, where Mars and Earth experienced a second ice age, but this one happened to change Mars, not Earth, because Earth managed to survive its second snowball Earth. Mars didn't. Let's talk about what happened 700 million years ago, shall we? Alright, so now we're going to get to the period of 700 million years ago. And this is during the time when both Earth and Mars went through a second snowball period. And this is the time when oxygen levels, like I said, were much higher than the CO2 levels. And on Earth, it was actually the concentration because Rodinia was splitting apart. As Rodinia, the supercontinent, was splitting apart, it basically changed and altered early Earth's climate around because it pretty much reshaped, ocean currents. It pretty much, these life forms have changed a lot. Earthquakes, volcanism, all of that stuff. And then that triggered something as these plates were moving around. And like I said, this impacted the climate pretty bad. So now you had a very long period of snowball Earth. And like I said, that was like the first of many ice ages in the past that basically the first couple extinction periods that happened on Earth. But Mars had the similar part as well. But this was a little bit different because here's what was going on 700 million years ago. The sun's luminosity already increased now. It's about close to what it is today. And this is during the time when the sun was actually very violent. The sun stripped Mars of its atmosphere, and not just its atmosphere, but its magnetosphere away. But also, this led to its interior, because now without all that atmosphere and the long time exposure of radiation that was getting to it, Mars cannot retain heat. Also because Mars is half the size of Earth, so the heat can only stay on a planet for that long. But Mars being smaller than Earth, and now as it has a thin atmosphere now, Mars cannot retain heat. So the planet's interior froze all the way through to the core. The core stopped spinning, couldn't generate enough current to pretty much create a magnetic field to protect Mars from solar radiation. So Mars is always getting hit by constant solar radiation. And this led to, trigger another ice age. But actually, this is a permanent ice age that Mars is still dealing with today. But here's what's different. Mars is 95% CO2. But guess what? CO2 is very heavy indeed, because the CO2 has managed to stay. So as the ice kind of sublimated, it kind of evaporated. All that water ice evaporated. But do you know what was left in the ice as the ice was kind of sublimating and then kind of receding up to the poles? Frozen CO2. CO2 is heavy. So that's why Mars never recovered from the snowball Mars activity 700 million years ago. Because, like I said, the water was stripped all the way out into space. And its atmosphere was stripped into space. Its magnetosphere was stripped into space. That triggered a permanent ice age that just, over time, just sublimated or condensated. But it was left over, all that water, all that vapor was just, exiting out. It was just going on into space. CO2 is left over. So yeah, Mars never recovered from that. So this is what actually shaped Mars today, was a permanent ice age that Mars can never get out of. And we want to understand that from the ESCAPADE mission. These twin spacecrafts are going to be studying that, understanding what happened to its early atmosphere, what happened to the atmosphere today. Like, how much is the atmosphere left today? How much is the magnetosphere still left? And just the concentration of solar particles that's interplaying with its early atmosphere as well. We want to understand what happened during that phase period. But we talked about the ice age that triggered that event. And remember, this is the comparison that Earth went through, but Earth actually managed to survive that because of volcanism. The Martian interior froze through, so volcanism didn't save Mars at all. It just didn't, because its atmosphere was stripped off and, interior just froze over. So no tectonic activity anymore. So Earth managed to survive multiple glaciation periods if it wasn't for volcanism. And yeah, life thrived on Earth. Mars is a red, barren desert. Frozen desert, actually. But we also understanding evidence of the ice caps as well, too. Because, that also interplays with the concentration, the chemical makeups of its atmosphere, because like I said, most of Mars' atmosphere is CO2. So that's pretty much what I want to talk about today, understanding ice ages on Mars, and how Mars went through a permanent ice age. So thank you guys so much for watching. As always, keep exploring. Also, if you guys have any questions about space, I am very happy to answer this on a video or in the comments down below. So yeah, I'll see you guys in the next video. Bye.